Chapter 1 Video 1. This is basically going to cover the first third or so of Chapter 1, the study guide. And on the screen there we've got our Hello World program. But I'm actually going to start this by creating a new Java class, which we can do in IntelliJ just by hovering over this Java folder here and right-clicking and selecting New and Java class. I'm going to create a class called Animal, which will crop up throughout this course. We'll gradually enhance it and change that as the course progresses. And IntelliJ creates it for me. So the first three lines there are just comments, which we'll talk about in a minute. And the entire declaration of the class so far is just these lines 4 and 5. We've got public class animal, and then we've got some curly brackets. And it's within the curly brackets that we're going to actually define our class body. So the three keywords so far: public is just the access modifier for the class. That public basically means that you put no restrictions on any other classes that may want to use it or reference it. Class is the keyword because we're creating a class here. And animal is what we've decided to call it. It's the identifier. At this stage you just need to know as well that you don't have to have public there. It can just be called class animal. And there are other levels of access other than public. There's protected and private. We'll talk about those in more detail later. But for now you just need to know that you don't need an access modifier there, but 90% of classes will be public. They'll be public unless there's any reason for them not to be, basically. So that's our class skeleton. So classes basically contain fields and methods. So let's put some fields in there. Let's put a name and a type. So fields are like properties that are pertinent to the particular type of class that it is. So an animal may well have a name and a type. And these two properties are of type string. So string is just a string of characters. It's a way of just representing words as a Java type. So we've got two properties there, and we're now going to create some methods. And methods typically are some sort of action that interacts with those fields. So we're going to create a very common Java pattern here. Some access methods for those types, and they're so common that we can get IntelliJ to help us here. We can do right click, generate, and if we select getter and setter, and it's asking you, well, which of your fields do you want to create getters and setters for? So I'm going to highlight both of them and click OK, and there we go. So we now have some fields and some methods, and we have two fields, and for each of those fields we have a getter and a setter. So we have 4 methods in all: a getter and a setter for name, and a getter and a setter for type. So let's just have a closer look at these methods. So methods, this is the entirety of one of the methods here. Again, it's characterized with the beginning and an ending curly brackets, which define in which you define the body of that method. The method signature looks quite like the class signature. We've got public, again that's the access modifier, which again we don't have to have the access modifier, or there are other levels other than public. Public just means there's no restrictions whatsoever. The next word is the return type of the method. So this method, when you call it, is going to return a string to whatever is calling that method. Then we have the name of the method, which in this case is getName. Then this is how you can always recognize a method. It's got round brackets after the method name. They always have that. Sometimes the round brackets are empty, and other times they're not, as we'll see in the next example. And then here's the body of the method. It's just going to return name. So whoever calls it is going to have this field returned back to them. So if they want to know what the name of the animal is, they call this getName, and it will return that variable to them. So the next one is setName. A very similar looking method in that it's only got one line in its body, but this is different. It doesn't have a return type, so whoever calls this method is not going to be given anything back after they call it. It's effectively like a fire and forget method, as you don't get anything back from it, as it's void. This time it's called setName, and this time there is something in those round brackets. We're passing in a string called name. That's because these round brackets are a way of being able to pass some data into a method when you call it, like a parameter. So when you call set name, you're going to be setting this name variable here. So you pass in the name that you want to set it as a string, because it has to be a data type that matches the one you want to set. And then we're simply going to say this.name equals name. So this is a keyword in Java which means this particular animal, this one, because you can create many of them. This animal, set its name to whatever one you've passed in as this parameter. So getter and setter is a very common Java pattern, and we're just using it here to illustrate what the difference between methods and fields in Java. Exactly the same for type here as well. So you've got an animal class with 2 fields and methods to get and set those fields. So how do we actually run a Java class? How do we turn this in from just a Java source code into an actual executable Java application? Well, what we need for that is a particular method with a particular structure, and we've already come across it when we did hello world. So that's the method structure here. So animal doesn't have a main method, so we're going to have to create one. But what I'm going to do, I'm not going to put it directly in animal method. I'm going to create yet another class. So let's do that here. New Java class. And I'm going to call it zoo. As you can imagine, we're going to be putting some animals in our zoo. So again, that creates the method skeleton for us, the class skeleton. So I'm going to put a main method in this. And in IntelliJ, you've got the shortcut of PSVM and then tab, and it creates that method signature for you. So this, when you want to make a Java class an executable Java application, this is the method signature you need, this very specific one, because when you run a Java class, a Java virtual machine is launched, and that Java virtual machine needs to know where to start its thread of execution, and it looks for this method called main. Again, it's public, it's static. Now that's something we'll cover later in the course, but for now you just need to know that static means that this belongs to the entire class. It doesn't belong to any instance of it, and it can be run without creating any instances of the class. So don't worry if that doesn't make much sense so far. We'll come back to it. Void. So as before, when we use the set name method, it's not going to return anything to the caller. When you call this, it's like a fire and forget. Main, that's important. It has to be called main, and then we are passing a parameter into the round brackets of this method. So this square bracket might seem a bit strange to you. If we did that, that would be understandable straight away. We were basically saying that to call this method, we're passing a string into it. But if you can imagine, a Java application might need to have several parameters passed into it at runtime. So the square brackets indicates that this is an array of strings, so potentially several strings. And we also need to know for the exam that this can also be represented like this, with ... Since I think about Java 7, that's been another way of representing a Java array. But for now, we'll do the much more common square brackets, because that's been around since the start of Java. So if we were to try to run this as a Java application, it would be runnable now, because the JVM, Java Virtual Machine, would say, yes, it's got a method called main. This is therefore the starting point of this application. So what do we do in our main method? Let's create some animals. Animal tiger equals new animal, and animal elephant equals new animal. So what have we done here? What we've done here is we defined an animal class before. Here it is. And what we're doing in our zoo class is we're actually creating some concrete instances of that class. So this new keyword is the thing here, the pertinent thing here, because what that basically does is when you use new, it instructs the Java virtual machine to create an instance of that object and put it on the heap in the memory. So we're creating an actual concrete instance of our animal class there called tiger, and one below it called elephant. So, and then once you've created an instance, you can call methods on that instance by using the dot operator. So let me do dot here. And you can see that the first 6 of those entries are the things that we ourselves defined in the animal class. The name and the type, and the methods to get and set that. There are some others as well later in the list, and we'll cover those later in the course. But for now we just want to set the name. Let's set it to Terry the tiger. Terry. And we'll do the same with the elephant. Name. Call it Erica the elephant. So we've got 2 animals. Now we can just do a system out to the screen to tell us what we've got in our zoo. So to do a shortcut for a system out, you do SOUT tab, and that gives us the shortcut. And we'll say this zoo has a tiger called, and then when you're dealing with strings, you can use the plus operator there to concatenate some strings together. So we'll do tiger dot get name this time. So we've set the name here, and now we're going to get that name again to print it out. And then we'll do this. This zoo has an elephant now as well. And called elephant dot get name. So now I'm going to actually run that class. So to create in IntelliJ, to create a runnable class, you right click and choose this create zoo.main, or create whatever class it is you happen to call it, and a dialog box comes up, and I'm just going to say yes to all the defaults there. It's going to create as a runtime configuration, so OK to that. And now I can go to tools, I can go to run here, sorry, I can run. So now I can go to run, click run zoo, and it will parse and compile and run that class. And there we go, there's the output from that class, just as we expected. So let's just look a bit more closely at what's going on here. We're saying animal tiger equals new animal, and we already said that new tells it to construct a new animal object. But how does it know how to construct an animal object? Well, the clue is here. We're saying animal with round brackets, and we said before that when you have round brackets after something, it's like a method call. But this is a special kind of method call. When you have the name of the object followed by round brackets, that's actually a constructor. That's actually a special kind of method called a constructor. So I'm going to click on that. And in IntelliJ, you can click between methods and constructors and fields by clicking Control and the left mouse button. So let's take that back into the animal class. It takes us here, and if you actually look at what's written in the animal class, well, we haven't actually defined that constructor that's just animal with round brackets after it. We can put it in. Let's do that now. And I'm even going to start to comment this class a bit. Here are our fields. Here are our methods. And here are our constructors. Now there aren't any constructors there at the moment, so let's put one in. Constructors. Public animal. Like that. There we go. So now if we go back to zoo again and click this, now it takes us to exactly what we just wrote. So you might wonder, well, wait a minute, we've only just coded that. How on earth did it work the first time? Well, the reason is that when you create a new class, you'll get this default constructor like this, which has no arguments and does nothing in the body, for free by Java. It'll just create you an empty object. It won't set any of the fields or anything, and it'll put that on the heap for you. The only reason that you can override this default constructor is if you want to actually do something, like you might want to set one of those fields to have an automatic value, or you might want to create another constructor to give calling code various options how they might want to create this class. So let's do, I've copied that, but now I'm going to do string name again, and I'm going to do exactly the same thing as the setter method here does. So I'm going to copy this directly from the setter method. So now we've got two constructors. One is the default constructor that does nothing, and then we've got one here that passes the name in, so that when that object is constructed, it gets this name passed to it, and this ends up getting set. For now, we'll ignore the type one. We'll deal that with in later videos. I said before that you get this default constructor for free, but if we actually delete it and go back to zoo again, you can see that the zoo is no longer compiling. That's what this red marking is here, and that's because whilst it's true that you do get the no arguments constructor for free, you lose it if you then define another constructor, as we have here. So if you want that no arguments constructor, you have to put it in explicitly yourself, but actually we don't. We'll just do it here. We'll just do Terry and Erica here, and we don't therefore need these setters because we're doing it in the constructor. So if we run that again, that will now use that will give us the same output, but it's done it through a constructor this time. It's set these names through a constructor, and I'm just going to take it one stage further now, because we explained here that we've got this string args array, this array of strings, but actually we're not using it at all. We can use that to pass in arguments at runtime, but we're not actually using it at all. Everything we're doing is kind of hard-coded in the method. So let's actually use that to call this constructor. So instead of just putting Terry there directly, I'm going to say get what's in args, the very first thing in the args array, and it's indexed from 0. So we have to make sure we set it at 0. The elephant's name is going to come from the second one there, args1, and I'm even going to just add another thing now, system out again, and just a welcome message to welcome to, and I will then put something else that we need to get from that array, so we can put a message in there. Now in IntelliJ, the way you can pass in program arguments like this to fill this parameter are through the runtime executable that we created before. So let's go to edit configurations, and you can find here is the zoo one we created before, and we can put the program arguments here. So we're going to put the tiger's name, which is Terry, elephant's name, Erica, and then I'm going to call it John's Zoo. But we have to be careful here because John's Zoo is actually 2 strings, so we have to just force it to be 1 by using double quotes like that. So I'm going to apply that and OK it, there, and run that again, and there's the output, exactly the same as before, but this time we've utilised the args string array and our new constructor there, passing it in. So the next thing to look at is comments in a Java class. So comments basically come in 3 flavours, and you can see when we created our new classes from scratch, they've already created one of them for us here, and this is called a Javadoc comment. It starts with a / and 2 stars, then any subsequent line needs to be starred like that, and it's terminated with another star or asterisk and the / again, and we can write whatever we want in here. So zoo class to all animals, for example, we can write whatever we want in there, but it should be something meaningful and well written, because these Javadoc comments go to create official documentation for the class structure. So what we can look at to demonstrate that, we can look at the string class here, which is obviously a very fundamental Java class here, and you can see here this is the string class that's opened in IntelliJ for me, and you can see there are comments all over it. There are these Javadoc type comments all over the place, and if we look at the actual official API documentation for the string class, here it is, you can see that there's lots of documentation here, and that's all been generated from what's been written in the source file itself. It's handy to make a note of that URL, by the way, because this is where all the Java documentation can be found. Another type of comment is a double / like I've done here. This is just like a note to yourself, and it's not going to appear in the Java docs. So I've just made a note to myself, well, here are my fields, here are my constructors, and here are my methods. Another thing you can do, you can use that type of comment to just comment something out. So if I just do that, for example, I'm basically commenting something out so it doesn't get read by the compiler. You're effectively deleting it without actually deleting it, because you might want it to come back later. And another type, that's a bit messy, using 3 of those type single line comments. You can do a multi-line comment, so it's a little bit like Javadoc Comment, but it's / and a single asterisk. Then you go to the section to the end where you want to stop doing it, asterisk and single / again. So we commented out that entire method. So 3 types of comments exist, and it's just important to know that these two, the single line and multi-line comments, they can be used for actually writing genuine comments for the developers who write the code and who we're going to use it later, or they can just be used for commenting something out like that. Javadoc Comment should always be well written and not used for commenting code out, because those comments could potentially appear in your Java documentation if you generate it. So that's the 3 types of comments there, briefly covered. Another thing to point out is that when you create a public class like this, a file will be created on the file system of the same name and of the same path. So you can see here that we're in this path here, this Java Test Examples project, and we're in the source main Java folder of that project. So if I'm to look in my Windows Explorer, if we trace that path along, you can see I've got my animal and my zoo class have been created there, along with Hello World as well. And if I were to change the name of that animal class here, just put a typo in there, it will complain. Complain firstly because this constructor is now wrong there, so we can change it like that. But it will now complain that as this is a public class, it should be declared in a file of the same name, and it's not. So public classes should always be declared in a class in a file of the same name. We can also put multiple classes in the same declaration, the same file. So if I went to the very end of here and put another class here, I'm just going to do class human, and that's fine, that compiles no problem. The only thing to bear in mind is that you can only have one public class per file, and the file has to be named after the public class. So that's okay to do this, but if we were to call this public, it would complain about it, because it's saying that it should be declared in a file called human.java. So we'll actually get rid of it altogether. That was just to demonstrate that principle there. So the next thing to talk about in this video is package structure. Basically all these files, these Java classes so far, we've got 3 here, they've all just been created directly in this Java directory. But of course when you write a large project, you're going to end up doing declaring and defining lots and lots of classes, potentially hundreds. So you need a way to organize them, and we do that through what's called packages. So I'm going to create a new package here, new package there. I'm going to call it com.javajohn, my YouTube name, .study.zoo, where I'm going to put up my zoo classes. So that's created a new package, and what you can do, you can just actually control and left mouse click to highlight whatever classes you want. You can physically move them into there using IntelliJ, and click refactor, and that will do that. And what you'll see is that IntelliJ puts in this new package declaration here. So what that effectively is, it's a folder system. So if you looked on your Windows Explorer at your folder directory structure, you would see that directory structure has been created and those files have been put into it. So it's a way of organizing your Java classes, and it's also a way of making them unique, because we're creating classes here, like a class called animal, for example. If somebody else in some other office is creating a class called animal, and both of these get released into the public domain, you need to be able to know a way to distinguish them. So you give your package name as unique a name as possible. It's often based on a web domain that you might have, so that your animal class can be distinguished between anyone else's animal class. To use and reference other classes in a Java class, you have to import those classes with the explicit use of the keyword import. But you might be wondering here, I mean, we've got the zoo class here, and this is using other classes. It's using animal, it's using string, it's using system. You can always tell classes because they've got the uppercase first letter, and it's not doing any import. You don't see any import statements here, and that's because there are some exceptions. You don't have to import packages that are in the same package as yourself. So zoo and animal are in the same package, so they don't have to import each other. And classes of the package java.lang you get imported automatically for free, and system and string are examples of that. So you don't have to explicitly import the package java.lang. So we can illustrate this by referencing a class that doesn't come automatically for us in the java.lang package. Let's try date. Let's have a date of birth here. This time the compiler doesn't let us get away with that as it does with string. This date is red here because it doesn't compile, and there we go. IntelliJ will prompt us by saying, well, what date are you talking about here? So we can do Alt and enter, and it'll tell us the different types of dates that are on our class path. Lots of different classes called date on our class path. We have to tell it which one it is by importing it. So let's go for that one, java.util.date, which is the most common one there. Problems occur. You can get clashes with these things. So if we also import java.sql.date, now it's telling us, if we hover over date, it's saying no, this is ambiguous because we're importing both java.util.date and java.sql.date. Which one is it? That compiler would fail at that point. And despite the red line there, it's important to note out here that there's nothing actually that will fail compilation about clashing import statements like that. It's actually when you do this where the problem comes in, where you actually enforce that actual clash. So the compiler error here is on line 13. So the way we could get around it, obviously we could just delete one of those two and then it would work. But what if we genuinely did want a java.util.date and a java.sql.date? Well, what we could do is one of them, we could explicitly give the full package like that. Well, date like that. And then we could we could either delete this. In fact, what I'll do, I'll comment it out. So we can delete that one, and that now all works fine. But what if we do want to use other classes from the java.sql package? Well, what we can do is we can use the wildcard. We can do this, and that will import everything from the java.sql package. And as we've explicitly imported util date, that's the one it'll use for dates, unless we otherwise say here. There's something to consider about using the wildcard in import statements is that sub packages don't get imported when you do that. So to illustrate that, I'll just go to these API docs again, API documentation classes, and here we are. This is a list of all the different packages you can import. So if we look at java.security, for example, if you imported java.security.star, you would get all the classes that are defined in that package, but you wouldn't get all of these ones, these sub-packages. You would have to import those independently. So the final thing to cover in this video is actually how to run Java from the command line, because we're doing everything in an IDE here, IntelliJ, which makes things nice and convenient for us, but we have to be able to do this from the command line as well. So what I've got in Notepad++ here, I've actually defined a couple of classes already, just written them in a text editor, which is obviously the way things used to be done. And you can see here I've got class A, which just has a name variable and a getter for that, similar to our animal class. And you can see here that it's that's the path to it. Java Study Package A Class A, and indeed that's got this Package A declaration there. Class B, which is Package B, imports class A, and it uses that getter to get its name and prints it. And again, you can see here it's on C Java Study Package B class B. So I've opened up a command prompt at this level, at the Java Study package level, and I'm going to compile those classes. So we use the Java compiler, and it's package A / class A dot Java, like that. And that's gone without issue, so I'm assuming that's worked. And then we'll do the same for class B, which is in package B, like that. And that's worked too. Now we just want to run them. So class A doesn't have a main method. So what happens if we try and run class A? We do Java, and we do package A dot class A. We don't need to put dot class or anything like that, just like that. And here we've got an error. It's saying that the main method is not found in this class. As we said before, to make this a runnable Java application, it needs to have the main method. So let's try with package B class B, and that works fine. Class A's name is Charlie, which we've put there explicitly. So that's how to run Java from the command line. I just opened up my system environment variables dialog here, just to explain that to actually be able to run Java on the class path as I just did, you need to tell it where Java is. So I've set up this variable called Java home here. I've pointed it to where my JDK was installed when I actually installed it. Then what I've done is to my path variable here, I've edited it and added to it. So if I open this up, I've edited that Java home, which I just pointed out before, and then the bin directory within it, because it's within that bin directory that we get the Java C tool, the Java tool, and many others such as Javadoc. So make sure those are set before you attempt to run that Java from the command line.